204, so you can. Now this is the one you were doing for homework, and I've just drawn it out here. So it says the vertical distance between a crest and a trough is 24 centimeters. So vertical distance is this distance. That's the full distance, 24, and you know that's the full distance from a crest to a trough. But amplitude is only from the middle to the top or the middle to the bottom, so you're going to have to halve that to get the amplitude, 12 centimeters. The horizontal distance between the first and the fifth crest, so I've done in 5 crests, 1, 2, 3, 4, 5 crests, and the distance from there to there is 40 centimeters. But count the number of waves. So you want the wavelength from that. Well, there's a wave, there's a wave, there's a wave, and there's a wave. That's 4 waves. So they're tricking you by saying the first to the fifth. There's only 4 waves. And the full distance is 40 centimeters, so one wavelength is 10 centimeters. So I've written in wavelength here. Now what I could have written was lambda. So that Greek symbol which looks like a backward H. Lambda for wavelength. Now, it then says if 30 such waves pass a fixed point every minute, 30 waves per minute. Now, you need to think about frequency as being the number of waves per second. Well, 1 minute is 60 seconds. So for frequency, I've got 30 waves per minute, which is 30 waves in 60 seconds, but you need the number of waves in 1 second, so it's 30 divided by 60 gives you 0.5. So the frequency is 0.5 hertz. And then the last thing it says to find the speed. So to find the speed, you're using the wave speed equation that you'll be given. V equals F, frequency, times lambda, which is the wavelength. So then you substitute V, the speed, equals the frequency from up here, 0.5, all right, times the wavelength from up here, 10, okay, so that gives you 5, and put in your unit for speed, meters per second, all right. Now, there's another, I'm going on to do sound now, but there's another question on that. I'm going to post it up as an assignment, but there's another question similar to that. So what I want you to do, because some of you were getting that last one wrong, I want you to do what I'm doing and draw out with the information to give you the way I've done. Well, actually, it mightn't suit that too well because it's a longitudinal wave. Now, for a longitudinal wave, so the question I'm giving you is in the book, the first one in there, the chapter questions. So the longitudinal wave, consider a crest to be from where each compression, the middle of each compression, where the waves are closest together. So that's a crest, 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 crest. It's 1, 2, 3, 4, 5, 6 crests. That's 5 waves. 1, 2, 3, 4, 5 waves. So don't be tricked there. Okay. Now we're looking now at page 205, sound. So I'm giving you homework, which is notes on this, but I'm putting up a YouTube of me explaining this, what I need you to know on sound. Now, well, I'm actually explaining it now, but there's an extra wee bit on the YouTube video. So we would have done this in junior. So you'd have slapped a ruler and it would have went up and down like that. Well, as the ruler's vibrating, it's making the air particles vibrate and they compress, and then they stretch out a rarefaction, then the compression, rarefaction. So it's a longitudinal wave. Now you've drawn a longitudinal wave where the vibration's going like that and moving along, but it could also be like that. It could be in any direction. So as I'm talking, my vocal cord is vibrating, making the air vibrate, which travels through the room. So any sound, so we would have done this in junior, slapped the ruler and it would have made a vibrating noise. Any sound, if you think of it, is something vibrating. Okay? And they're longitudinal waves. Go back and think about longitudinal waves again. Longitudinal waves is going to be the first question in any test. Longitudinal and transverse. Sound is longitudinal. Light is transverse. Now, I'm hitting the desk. You can hear that loudly. Why? Because the desk is solid, and solids carry sound really well. As I'm talking to you, I'm talking through the air. air's a gas. And even though we're normally hearing sounds through a gas, that doesn't mean that the sound doesn't travel well through a solid. It does. It's just more unfamiliar to us. Okay, so that's the example we would have given you in junior, where if you were the Cowboys and Indians and you were trying to get away and you wanted to hear how far they were behind you, go down to the ground, put your ear to the ground so you could hear the horse's hooves. Because you could hear the horse's hooves traveling, the sound travels faster through solid than liquid or gas. Now, and the other thing we'd have done in junior was that light travels really, really fast. It comes in at a really high speed, and the sound is slower than that. So thunder and lightning. You can see the lightning, immediately it happens, but it takes time for the sound or thunder wave to roll into you. So where the lightning, thunder and lightning is, if it's a mile away, well, you see the lightning as soon as it happens because light travels so fast. But then you hear the roll of thunder about 3 seconds later because it takes that length of time for the sound to travel to you. Okay, and then there's this wee bit here that as the YouTube video that I'm putting up, where you have a wave that looks like this. That would be on a cathode ray oscilloscope, which is a machine to turn waves into something that you can see. So somebody who would be having heart problems, for example, you'd see these waves up on the machine beside their bed. Well, there's a wave, and the loudness will be determined by how high up the amplitude is. This is a louder wave. It's a much higher amplitude. Now, I've gone over this on YouTube. This is frequency. This is a frequency. This is a higher frequency because the waves are closer together. So there's questions here on these questions on page 205. So that's for your work. I want you to go through the notes on page 205 and write those down. Now then we're starting hearing. What can we hear? Well, we can hear very low down waves. So if I try to talk very low down in a very low frequency, you can hear what I'm saying. This is low frequency. But if I was able to go even lower frequency than that, lower than 20 hertz, lower than 20 waves per second, you wouldn't be able to hear me. Why not? Because human hearing can only hear anything higher than 20 hertz, 20 waves per second. Now, what can we hear? Well, if I start to talk in a higher pitched voice and I'm going higher and higher and higher, I am eventually going to go so high that you can't hear me. Well, then that's 20,000 hertz. 20,000 waves per second is the highest humans can hear. Okay, and that's 20 hertz is the lowest, 20,000 is the highest. So we say we can hear between 20 hertz and 20 kilohertz, because 20,000 hertz is 20 kilohertz. Now, at the minute you can hear that. I mightn't be able to hear that because I'm older. And you all know elderly people, they can't hear the higher frequency. So the elderly people, their eardrums are that bit less tuned into the higher frequencies, and they can't hear the higher. So anything near 20,000 hertz, 20 kilohertz, the elderly can't hear it. So the older people find that difficult to hear. And if it gets so bad on them, they're going to have to get a hearing aid. Okay. Now, obviously, other people may not have good hearing, but the question you're mostly asked is about elderly people and what has happened to them. Well, maybe they had a life where they were driving a machine, and in those days didn't wear, the big earmuffs that you see now. Anybody using a heavy machine, working on the roads or working in heavy machinery. And that wasn't commonly worried about in the old days. So people have got damage to that. Maybe they've had an illness that's damaged their eardrums. Maybe they're being idiotic and going around with headphones stuck into their ears and their music turned up too loud. That is definitely going to cause a wave of deafness in your generation in days to come. So what are you supposed to do? You're supposed to protect your ears with earmuffs, protect them from loud sounds. So that's page 205 and a wee tiny bit of 206, and I'm going to post that all up as an assignment for you to do until Monday. And then I'm putting up more work on Monday, guys, on ultrasound. I want to be as finished this chapter as I can before the St. Patrick's Day break. So we're in Monday and Tuesday getting work done. Finish up, then use your holiday, Wednesday, Thursday, Friday to be ready to go back after that and get your work. The start of this, with the year 12s being the most important people in school, with the assessments ahead of you to get the evidence for your grades.